This will be for the pre-calc chapter 5 review problems. All right, the name of the chapter is Translation Functions. Match the graphs in figures 532 through 534 with the functions in problems 1 through 3. All right, so we have 3 graphs, and we're going to use those for problems 1 through 3. All right, so let's see. Problem number 1 is radical x plus 2. So you'll notice in problems 1 through 3, these are all spin-offs or translations of the function y equals radical x. All right, or I should say f of x equals radical x. So let's take a look at that graph first. So if you recall at the beginning of the chapter, we covered the graph of y equals radical x. All right, if you plug in x equals 0, you'll get y equals 0. If you plug in x equals 4, radical 4 is going to be a 2. All right, if you plug in x equals 9, radical 9 right here is going to be a 3, and so on. Okay, so that's y equals radical x. All right, so right here in problem 1, the plus 2 is underneath the square root. Okay, so right here, we added 2 to x. All right, we added 2 to x. And what does that make it do? Well, remember when you add or subtract from x, it's the opposite, so it shifts left. Okay, you add 2, it's going to shift left 2 units. All right, so let's look at the graph that shifts left 2 units. All right, so this one is upside down. And I can see figure 532, we're called the y equals radical x. It was basically like this. And see this graph? See this graph right here? It shifted 2 units to the left. All right, so figure 532 is matched up with problem number 1 because it shifted left by 2 units. So number 1 is 5.32, figure 5.32. All right, number 2, once again, the plus 2 is underneath the radical. So we added 2 to x, that's going to make it shift left by 2, like we said in the first one. All right, that's going to shift left 2 units. Now, this negative sign is multiplied times this whole thing. All right, the negative sign is not just times x, it's times the whole thing. So the negative sign is times y. All right. So that's going to be negative 1, or I'll write negative 1 multiplied, all right, y multiplied by negative 1. Remember, when you multiply all the y's by negative 1, it reflects over the x-axis. All right, so it's shifted left by 2, but it's also reflected over the x-axis. Let's take a look at the graphs again. So in the first problem, we already did the shift left 2 units, all right? So we actually have that graph already. But the second step is to reflect it over the x-axis. Here is the x-axis, and all we have to do is use this line right here as a mirror. All right, so this figure is now the same thing as here, but it's below the x-axis. It's the same thing. So this here in blue is what we're looking for. And if you look at this figure right here, 534, that's exactly what we have. All right, so we started with the original, we went over 2, left 2, and then we reflected over the x-axis. So this right here matches number 2, 5.34. All right, finally, number 3, notice the plus 2 is not underneath the square root like these two. So the plus 2 is not added to x, the plus 2 is added to y, okay? And when you add to the y, that makes it go up or down. So adding to the y makes it go up 2 units. All right. And the other thing here, see, this negative was outside of the square root. It was multiplied by y, but this negative is inside the square root. The negative, or negative 1, is multiplied by x. So negative 1 multiplied by x. Remember when we said it's multiplied by y, it reflects over the x-axis, but negative 1 multiplied by x reflects over the y-axis. All right. So let's see. We take the original, we go up 2, and then reflect over the y-axis. Okay, this is the only one left over. This is the only graph. So let's make sure. All right, the original y equals x was like that. So did we go up 2? Yes, we definitely did. 1, 2. We started right here. And as you can see, the y-axis right here is acting as a mirror. All right, because if this was moved up 2, it would be up here. All right, the graph would be up there, but it's reflected over the y-axis going that way. All right, so it went up and then it was reflected. I don't think the order really matters, but this right here goes with problem number 3. All right, number 4, the graph of f of x equals this right here. And they want you to answer what shift was applied by doing this. Okay, so we start with f of x, and when you add plus 2 outside of the parentheses, the plus 2 makes it go up 2. But when you do plus 1 inside the parentheses, you're adding 1 to the x. So remember, when you add to the x, it's for the left, right, but it's reversed. So plus 1 actually makes it go left 1 unit. Okay, so the plus 2 outside the parentheses, that's adding to the whole thing. So you're adding to the y. But the plus 1 inside, you're adding to the x. So left 1, up 2. Left 1, up 2. So that is answer B for number 4. All right, number 5, the solid graph in figure 535 is a graph of f of x. The dashed graph is the transformation. What is the transformation? I say we should get the coordinates for each one. Okay. The one with the solid graph, we'll label that S. All right. I'll just make a list of the coordinates over here. So the solid graph will be S, and the ones with the dashes, we'll call that D. All right. So for the solid graph, this point right here, the X coordinate is -4. The Y coordinate is -2. All right. And on the transformation, this point right here, x is -3, y is -1.
Excuse this interruption.
All right, -3, -1. Next point over on the solid graph. This one here, x is -1 and y is 0. And on the transformation, the dash graph, this is at 0, 0. All right, and finally, the last point on the solid graph right here, x is at 3 and y is at -4. On the dash graph, last point, x is 4, y is -2. All right, and now we want to see what was done to each x and y coordinate. I can see to go from -4 to -3, that's +1. -1 to 0 is +1, and 3 to 4 is +1. All right, so in each case on the x's, they did a +1. All right, so that means going from the solid to the dash graph, if you go from -1 to 0, that shifts right. So for the x, that goes right 1 unit. And for the y, let's see what happened. Here we went from -2 to -1, so it's +1. Here it's 0, 0, so it's not +1. All right, let's try something else. To go from -2 to -1, that is times 1/2. To go from 0 to 0, that's still times 1/2, because half of 0 is 0. And -4 to -2 is also times 1/2. All right, so for the y, it was times 1/2. All right, so let's write that transformation. We started with f of x. And what happens when x goes right 1? Remember, it's the opposite. Okay, so to go right 1, it's actually -1 on the x. Remember, we said it was opposite. To go right 1, you have to subtract 1 on the x. So instead of f of x, it's going to be f of x -1. All right, we subtract 1 from the x. And the y is times 1/2. Well, this thing right here was the original y. And now this whole thing right here is the new y. All right, and the y is times 1/2. So this right here is the transformation, 1/2 f of x -1. And that is answer A, 1/2 f of x -1. And double check, 5 is A. So that's correct. All right, so if you look at the graph, see if it makes sense. X -1 makes everything shift right by 1 unit. This one here to here went right 1. Here to here it went right 1. And here to here it went right 1. So that's good. And basically, what does 1/2 do when you do times 1/2? Well, that's vertically compressed. Okay, so if the graph was originally like that, then the new graph, it increases or decreases more slowly. Okay, so it's going to be more spread out like that. And if you look at the dashed one, it's definitely more spread out. Because you can see this angle here is smaller than this angle right here. So the dashed one is definitely more spread out. So it makes sense. But the most accurate way is to do it with the coordinates.